All right, in the next 10 minutes or so, I'm going to go ahead and go over 4-2B, which is just going to, like I said yesterday, find the missing sides and angles of right triangles using our triangle trig ratios that we talked about yesterday. So we'll be using our SOHCAHTOA once again, and then we'll find our missing sides and angles. So I'm going to go ahead and start with, here's an example where you have a right triangle that has a leg of x and a hypotenuse of 12 and an angle up here which is 36 degrees. You're trying to solve for x. When I look at this, I need to look at where my reference angle is, and that's going to be our 36 degrees, and everything's going to be based off of that. So when I see 36 degrees, our 12 right here, well, that's got to be our hypotenuse because that's opposite of 90 degrees. The side opposite, here's our opposite side, and here's our adjacent side. So when I look at the information that I have, I know what the hypotenuse is, and I want to find the adjacent side. So when I think back to my three trig ratios, which of those ratios deals with the adjacent and the hypotenuse? And that's going to lead us to our cosine function. So to set this up, we would take the cosine of our angle of 36 degrees, and that would be equal to the adjacent side, which is x, over the hypotenuse, which would be 12. Solving for x, since I'm dividing by 12 here, to get rid of that, I would multiply both sides of my equation by 12, and that would give us that x is equal to 12 times the cosine of 36 degrees. So we'd have to go to our calculator for this. Pretty much everyone should hopefully already be in degree mode. If not, you want to make sure you change that. So in your mode on your graphing calculator, you'll go over and you can hit, go down to radian, slide over to degree, hit enter so that the black bar highlights that, and then you can quit out of here. And we're going to go ahead now and take 12 times the cosine of 36 degrees and hit enter, and our answer is 9.71. So approximately 9.71 would be the length of x. Okay, another example here. Again, I have a right triangle where I have an angle of 15 degrees. The 26 that's right here, that is opposite of that angle, so that's going to be our opposite side. Our x right here, that's our adjacent side, and I don't have anything on the hypotenuse. So I'm trying to find the adjacent side given the opposite. So when it comes to opposite and adjacent, that's when we're going to set up using our tangent. So I can set this up as the tangent of 15 degrees is equal to the opposite, which is 26, over the adjacent, which is x, and that the adjacent side, which is x. Now just being really careful as you're solving for a problem like this, because in the previous one we had x in the numerator. Here we have x in the denominator. So if we're going to solve for x, we need to get it out of the denominator first. So multiply both sides by x. We now have x times the tangent of 15 degrees is equal to 26. Solving for x, I'm taking the tangent times the x times the tangent of 15, so we can go ahead and we can divide by the tangent of 15 degrees. So we go to our calculator, 26 divided by the tangent of 15 degrees, hit enter, and 97.03. So here we're just setting it up, figuring out if we're going to use sine, cosine, or tangent based off of the given information. I'll do one more example. So again, here's a right triangle. This one I left blank. I'm going to go ahead and put an angle down here of 19 degrees. And we'll say that the hypotenuse is 13, and we want to find x over here. So 19 degrees, I know my hypotenuse is 13, and x is the opposite side. And so that would set us up using the sine function. So the sine of 19 degrees is equal to the opposite of x over the hypotenuse of 13. Solving for x, I'm going to multiply both sides by 13. And so now x is going to equal 13 times the sine of 19 degrees. So go to your calculator. 13 times the sine of 19 degrees gives us 4.23. And you have it. So hopefully this is bringing back some memories from geometry when you first saw this. Now I'm going to shift gears, and what we're going to do is we're going to use the same idea, but this time we're going to find the angles. So if you are trying to find an angle of a triangle, you would have to have at least two of the sides. And so right here we're trying to find x. And when I look at x, the information based off of that reference angle here, we have the opposite side and we have the hypotenuse that's given to us. Opposite and hypotenuse, that brings me to using the sine function. So setting this up, I would have the sine of x degrees is equal to 32 over 47. So now it's like, well, how do we solve for that angle? Well, to solve for an angle, you don't just divide by the sine, because it's the sine of that angle. Here's where we use something on our calculator, what's called the inverse sine. And so that's with the, it's got a little power to -1 here. That's the inverse. And so what we're going to do is we're going to take the inverse of our trig ratio of 32 over 47, and that's going to give you x. So on your calculator, you're going to hit the second button and then sine, and then we'll take 32 divided by 47, and then we get 42.91 degrees. And there you have it. So to find an angle, you have to use the inverse function on there. Second example to look at here, solving for x. Once again, you have the hypotenuse side being given to you, and then with relation to x here, that 19 is the adjacent side. So the adjacent and hypotenuse, we're going to set up cosine. So we have the cosine of x degrees is equal to our adjacent over the hypotenuse. So cosine of x equals 19 over 35. To find our angle, we have to take the inverse of that trig ratio of 19 over 35, and that's going to end up giving you x. So inverse cosine of 19 divided by 35, and we've got 57.12. And there you have it. So again, this should all be review. What you're going to be looking at doing is setting up problems that are involved using some real world situations. So you're going to have to like set up a ladder that's going to go against the wall, but really what you're doing is you're just setting up a right triangle and trying to find those missing sides or missing angles. So you'll have the rest of the time to work on the practice problems. Also, if you finish those up, I put out your ACT questions as well, because you might want to go back and make some adjustments to those, since there are a few of these problems on there. All right, finished under 10 minutes, so we should be good to go. See you on Friday.